Okay, so now we will talk about the multiplication principle again, but what we talked about first was the counting choices, and now we're going to talk about counting arrangements. So how many ways we can arrange items. So we can arrange items, let's say we could arrange books on a shelf, or anything on a shelf, like in a grocery store, we could say like cereal on a shelf. Any kind of display of items. So display is a keyword, or the word arrange. So those are sort of keywords. Other kind of displays that you might not think of, words. The order that I put the words is the letters is a display, and if they are in a certain order, they actually read. You can read it to be something. So anything that needs to be in an order, like a phone number, a license plate. And then we could talk about people. So these are sort of displays of characters, like letters or numbers. These are displays of items, and then we could say of people. So when we're talking about people, the displays that we're talking about, maybe people are sitting in chairs. How about in a photo, or in line at a store, or people in a race. So you're counting how many ways. So there's lots of these. I can't list everything, but other examples would be how many ways can you write people's names on, a class list, or how many ways can you play songs that are on your iPod, something like that. So let's talk about words first. So we could say, how many ways can we arrange the letters in the word math? Okay, so there are 4 letters in the word math, and I could just start writing them. So we could count. One way to arrange them is in the order that they're given. Another way to arrange them would be to swap the H and the T. We could, and I'm not going to get them all this way, but I could keep going. So how many ways can we arrange the letters? And in math or in stats, we often call these words, even if you can't read the words. So I could write these all out, and if I kept sort of a good pattern going, I could probably figure it out. We could, because I said this is multiplication principle, we could try a tree diagram as well. So in that first spot, you're going to choose either an M, an A, a T, or an H. So in that first spot, I chose an M all the way here, but I could have put the A first, or the T, or the H. And then if I choose the M first, I can't choose the M next, so I either choose the A, the T, or the H. If I chose the A first, then I can't choose the A again, but I could choose the M, the T, or the H to be that second spot. And I could do the same thing here. I can pick the M, the A, or the H. And here I could pick the M, the A, or the T. So far I pick one of the 4 letters to go in the first spot. So here I just chose M. Then one of the other 3 letters to go in the second spot. And then the third spot, there's only 2 letters to choose from. I could, for this one, the T or the H. M, then T was chosen, so here I could pick the A or the H next. And here the M and then the H was chosen, so the A or the T next. And I could fill this in. But basically that third spot for each of these, here's the H and then the M, so I could pick the A or the T next. Okay, we'll just put a couple of these on, but you could fill this all in with the 2 letters for each. If I'd made it a bit bigger, I could probably do that. And then the last letter, how many choices do we have for that last spot? So this is a 4-letter word. In the first spot, I have 4 choices. In the second spot, I only have 3 because I can't put the M twice. In the third spot, I have 2 choices, and then there's just 1 letter left to pick from. So in that last one, if this is an arrangement H, M, A, then I have to put the T next. H, M, A, T. All right, so this, each of these, if you wrote it all out, multiply this. 4 times 3 is 12, times 2 is 24, times 1, so 24 ways. So I could list them. I could list those 24. I have 4 of them down here. Not doing it in a very good order, but if you did want to list them all, M-A-T-H, M-A-H-T, M-T-A-H, M-T-A, M-T-H, A, and so on. So if I filled it in, I could read them all off of here. Okay, so 24 ways. Now what if I gave a second word? So let's call this number 1. Number 2, same question, how many ways can we arrange the letters in the word, but let's give the word stat instead. So what's the problem? The problem is that the 4 letters are not different. 2 of them are the same. So if I were to, it's not going to be 24 ways, because if I were to draw the tree diagram, let's just start it. If we had S, T, A, T as my first choices, choosing a T here or this T here is going to look like the same word. So in my next, I say I could pick the T, A, or the T, but not really. It's just either the T or the A, because picking a T is the same as picking another T. And then here I could pick a T or an A, and so on. So let's just write a few of them out. So what I'm saying is S, T, A, T would be one arrangement. S, T, T, A would be the next arrangement. And then can I put the S and then the T again? No, I've got all the possibilities. So then I could say, what if it were an A here? T, T, S, A. I have no other option because switching these will not give me a different word. Okay, so there's a lot less, where when we did that with math, oops, if I swap these two, and then if I change that second letter to be something else, I can still do the second one. Switching these does look different, where switching these does not look different. Okay, so what we want to do is take out all the duplicates. So we want to basically divide this by something that will cut the 24 down to how many actual choices there will be. So what do you think the answer would be to this? Not thinking about the math, but just the answer. How many ways could we do this? Well, there's 24 altogether if all the letters are different. And then there's 2 letters that are the same. So every time, if I wrote all 24 of these, half of them would be the same. Whenever I switch the T and the T, it looks the same. So actually, if I divide it by 2, I will get the right number of ways. Now there is an actual formula for this, but that's the general idea. Okay, so let's see what the formula looks like. We call these indistinguishable permutations. And actually the word permutations means just that, arrangements. And indistinguishable means you can't tell them apart. So like in that last example, if you switch the T's, you can't tell it apart, it still looks the same. So the formula for indistinguishable permutations is this. Okay, so that exclamation point is a factorial. So it's an exclamation point after a number. And what it means, if you've not seen it before, is to take that number and multiply it by all the numbers all the way down until you get to 1. So that would be 120. 4 factorial would be 4 times 3 times 2 times 1, and so on. Just another note on factorial. 1 factorial would be 1, but 0 factorial needs to be memorized, and that's also equal to 1. Okay, so that's factorial. So here, this is the formula. What does it mean? Well, the n is the total number of letters. That you want to arrange. Or you could think of it as how many spots you have to put the letters in. And then that A, B, and C are any duplicates. Okay, so if we look back at the word stat, this would be 4 spots, 1, 2, 3, 4, 4 letters, 4 factorial, and any duplicates, there's 2 T's, so we divide it by 2 factorial. So 4 factorial is 24, 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. Which gives us 12. So what about the ABC? Well, if there's more duplicates. So if a letter or if a word has more than one letter that's repeated. So what would be a good example of that? Science. So science has 1, 2, 3, 4, 5, 6, 7. So 7 factorial. That's if all the letters were different, that would be your answer, 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Now there are 2 C's here, and there are 2 E's. So we're going to divide by 2 factorial and by another 2 factorial. Now, on your calculator, there is a factorial button. So mine is right here above the 4, and it's in orange. So before I use that button, I have to push the orange second function button. So I would do 7, second function factorial, so it puts that exclamation point. 5040, and then I want to divide. And anytime you're dividing by 2 things, think of that in as a bracket. We're actually dividing by both. You're not putting a multiply, you're putting a divide. So you would say that divided by 2, I don't need to put the factorial because 2 factorial is 2, and divide it by 2 again. So it's like taking that 5040 and dividing it by 2 twice. Or you could just divide by 4. Okay, so that's indistinguishable permutations, and it could be more complicated or harder words, but we'll stop that video for now and we'll start a different idea next.